DUCO Umbilicals is part of a large engineering construction company, a French-based company called Technip. It's the largest engineering construction in Europe and fourth or fifth biggest in the world. The business that we target is bespoke umbilical systems for the subsea oil and gas business, where we manufacture control umbilicals which provide the controls to remote oil and gas facilities in a marine environment. You can just imagine the umbilical cord for a baby, where the baby's livelihood is dependent on an umbilical. That effectively is how a remote offshore facility operates. It requires the controls via the umbilicals that we manufacture here. And we manufacture for all areas of the world, from the North Sea, Gulf of Mexico, Asia, Africa. So we're active in all sectors of the oil and gas business. We're in a fairly sensitive environment here, where we're adjacent to a river, which we utilise for transportation of our facilities to the international markets. So it's very important that we ensure the protection of our immediate environment. And even with the materials we use, we do try and minimise the quantities we have going into production. But where we do have excess, we feed that back into the supply chain. And also the benefits are financial. This year alone, we've saved approximately £250,000 through the environmental policies that we've put in place. What's pleasing to see in the organisation is by adoption of the ISO 14001 policy, which has given us the correct fundamentals, is that our workforce are very engaged.
What we're doing here, we're segregating as much waste as we can. All the waste is kept separate, so we can put back into use, basically recycled. That's what we're after here. Like, if possible, to get 100% recycle of all the products we use on this site. I'd say we're 95.7, 95.8% of everything on site doesn't go to landfill now. So we've got away from that, which is a really good step forward.
We try to identify every waste. For example, what you see here, the plastic tube, everything properly segregated, everything properly labelled. And as an umbilical manufacturer, we can supply you with an umbilical, and we can also recover that umbilical and recycle it. The umbilical itself is a combination of many different waste streams, and some of those waste streams are very valuable. Nylon, for example, is worth as much as £6,000 a tonne. However, it can be very difficult to extract. One of the heaviest umbilicals that we ever made weighed something like 185 kgs per metre. So we've got to be able to cut it into manageable lengths first of all, for a recycler to even have an opportunity to start to recycle the materials. So we've had to look very carefully at our methods for actually cutting the umbilicals up. In the early years we used still saws, but they were very time consuming, and for employees to cut up something, for example, of say 500 metres of umbilicals, which isn't really a great deal of waste for this industry, we could typically see our guys spend a few weeks just constantly cutting up umbilicals. But we have invested heavily, and today we are able to cut the same 500 metres up in a day, and we also get the recovery of the fluid. We have successfully, for example, on the umbilicals, diverted something like 631 tonnes from landfill. And to give you an idea of a cost today, to send umbilicals which can contain some residues which are classed as hazardous or can be, those umbilicals could cost as much as £800 per tonne to incinerate. So 631 tonnes at £800 per tonne, you can begin to see the huge costs that would be incurred. And literally nothing is thrown out. Everything is recovered. So the whole umbilical itself has a value. Every particular component. Abandonment of umbilicals is no longer an option. And the solution to pollution through dilution is not the slogan of our organisation.
This sheathing line, being one of the main processes, needed upgrading to accept bigger, heavier and longer umbilicals. All the water is there for is to chill off the extruded jacket we put round the umbilical. The old system, which we did have, was open-ended, and that meant that basically the volume of water was constantly discharged. Although it was under an environmental permit, there was vast volumes just virtually being drained out the tank. So we designed it to actually be more efficient. The new system now is a closed system. The water is recycled. Environmentally, it's 35% more efficient, and we save in the main round about 400 cubic meters of water which are not discharged.
We find that round the site we end up with a lot of IBCs partially filled with various types of fluid. If we can reclaim that fluid to reuse it, it's a major cost saving towards the company, and it's also a cost saving towards disposal of this fluid. So instead of paying for it to get disposed of, we're actually going to reuse it.
The decanting stations came about from a study of how we were actually managing waste from different parts of the site. The containers were multiplying, and gradually there was confusion as to the boundaries between the good and the bad, what was waste, what wasn't waste, and more often than not that could lead to, and did lead to, materials being cross-contaminated at high costs and potentials for disposal anomalies. So typically people would put waste streams into an IBC, put a label on it, and then somebody else would put a label on another one, put another one, and before we know it, we'd have 20 or 30 of these IBCs. And in the past, we've had good fluids in small quantities, maybe left over from a contract, but still worth several £100. And because our containers were small amounts, people have just automatically assumed that these are areas where they can just put their waste. And we've suddenly had somebody put a few litres of oil into several hundred litres of good unused fluids, and we've just wasted £1,000. The dedicated facility has addressed all that and made it much more manageable. So the decanting station really was to make the whole process of actually removing the waste to another container quite an easy affair, so that the operator could bring the materials to the decanting station, have them extracted, put into their final disposal container almost immediately.
The electric cables and steel components that go into our umbilicals, they are supplied on packaging, which is, the packaging is a steel drum. Once we use the product, the drum then becomes redundant, and trying to get the supplier historically to take the drums back was rather difficult, because from a financial point of view they're seeing it as transporting fresh air. So we looked at this again and thought, well, from a health and safety and environmental point of view, what can we do? So we designed the drums in association with the supplier so that the drums themselves became safer to the product, safer to the people who are handling them, and more importantly, the specification and design of the drum became an asset to the company that was supplying it, and as much that they would now take the drum back because financially it was viable. The old drums went down waste streams to scrap merchants. Now these new high-tech specified drums are worth quite some money, and they're reused and taken back to the supplier in France, Germany, Czechoslovakia and Norway. So it's a continuous cycle. So through the environmental management system, we've actually driven the supplier to realise his obligation.
The umbilicals, when they leave our site, are charged with test fluids, probably used somewhere in the region on a busy year, something like 750,000 litres of fluid. And one of the earlier means of obtaining the fluid was in 205 litre barrels, which you can appreciate. If we're using 750,000 litres of fluid, that's an enormous amount of barrels. The waste minimisation that came from this particular initiative was to look at a number of issues, really. How could we capture a lot of lost space? How could we actually store our fluids more economically? And how could we actually, reduce wastage in the event of any type of losses of fluids, recover them? So the bulk storage tanks then were the ideal solution to our problems, and we purchased the three behind us, which is three 20,000 litre tanks. The equivalent of these tanks prior to having them would have used up 300 barrels. The footprint surface area of the tanks is approximately about 12 square metres, whereas if we'd had 300 drums on site, we would have been using something like 80 odd square metres. The tanker deliveries for something like 60,000 litres of fluid may involve two journeys by a tanker, where equivalent we would have seen something like 27-30 deliveries. And the cost savings, depending on how much fluid we can buy, can vary from 7 pence a litre to 27 pence a litre, And certainly what we've seen during the last 4 years, looking at our consumption and looking at our cost savings during those periods, we've seen something in the region of £105,000 of actual cost savings.
If you want to run a marathon, you can talk about it, you can do the occasional training run, but unless you commit to it properly, you're never going to be able to run the 26 miles on the day, and you're kidding yourself on. And really, running a sound environmental policy is exactly the same. You can't just talk about it, you've really got to put the right effort in.